this example, we're going to graph the rational function, defined by r of x equals a quantity 2x minus 6 over the quantity x plus 4. Before we do so, though, we'll identify some key features of this function and its graph. To start, let's factor and simplify r of x. So we'll factor that numerator, and it'll be 2 times the quantity x minus 3, and that'll still be over the quantity x plus 4. In this case, all we can do is factor this expression. It won't simplify any further. Next, we'll state the domain and we'll identify if there are any holes for this function. So the domain, since it's a rational function, we're going to look at the denominator and see what values of x would cause division by 0. In this case, we have that expression x plus 4 in the denominator. So our domain will be the set of all x such that x can't equal negative 4, since x plus 4 can't be 0. So we'll have our set of x such that x is not equal to negative 4. In this particular example, nothing simplified when we factored that function r. And so we don't have any factor in the numerator and denominator. And that's what we're looking for when we're looking for a hole. So we know in this case that there aren't any holes. So I'll just state that there's no holes. All right, we want to find and state any horizontal asymptote for this function. As we look at this function, we can see that the numerator, that leading term, is 2x, so the degree of that numerator is 1. And the leading term in the denominator is x, so the degree is also 1. So the degree of the numerator and denominator here are the same, which means that our horizontal asymptote will be y equal to some constant non-zero number. What we'll look at here is we'll look at that 2x over x, and we'll see that that would simplify to 2. So our horizontal asymptote here will be the equation y equals 2. All right. The next thing we're going to look at is the vertical intercept. And this is just an important feature of the graph. So the vertical intercept is going to occur where this function hits that vertical axis. So we're looking at finding the function value when x is 0. So we'll find r of 0. And all we'll do is plug in 0 for x, so we'll have 2 times 0 minus 6 over 0 plus 4, which is negative 6/4, which will simplify to negative 3/2. So our vertical intercept will then be the point 0, negative 3/2. All right. And the last part we're going to do here is we're going to find any zeros and any vertical asymptotes for this function. So the zeros, when we look to find the zeros of a function, we're looking to determine where the numerator is 0. And we can see here that we have 2 times the quantity x minus 3 in the numerator of this function. So that means that the 0 of this function is going to be just 3. All right, and when we look to identify the vertical asymptotes, we're going to look at the denominator of that simplified form. And we see the expression x plus 4. So our vertical asymptote will be x equals negative 4. And again, that's listed as an equation as it's a vertical line. Okay, at this point, we have most of the key features. The last thing we'll see here is that it says to state the behavior of the function around the zeros and vertical asymptotes. It'll be helpful if we put all of the information we've just written down onto our graph before doing so. So let's start. The domain we'll see as we draw this graph, but let's start with that horizontal asymptote. So we're going to draw in the line y equals 2, and that'll be a dashed line. So coming over to our graph, I'll draw that in as y equals, that line y equals 2. Again, it is dashed so that it doesn't look like it's part of our function itself. And we'll label it with its equation y equals 2. Okay, so the vertical intercept, we'll put in that point, 0, negative 3/2, or 0, negative 1.5. So we'll graph that in. And then we found that this function has a 0 of 3, and that corresponds to a horizontal intercept then of the point 3, 0. So we'll put that in. Okay, next thing we have is that vertical asymptote. So we'll draw on that vertical line, and again, that'll be dashed. So we'll draw on this line x equals negative 4, and then we'll label it with its equation. Some arrows on the ends, and then that's x equals negative 4. Okay, so at this point, we want to find out what happens around the zeros and those vertical asymptotes. So what we really need to know is what happens on this left side of x equals -4. And we could, based on the fact that we know there's only one 0, and that 0 is +3, we could deduce that our function is going to be above that horizontal intercept or horizontal asymptote of y equals 2. If we want to look at this from more of our numerical perspective, it would be easier to just pick a value of x. So let's find out, I'll get rid of these question marks, and let's look at finding out the function value at -6. So we'll find r of -6, and we'll plug that in. So 2 times -6 minus 6 all over -6 plus 4, and that will equal -18 over -2, which means that it's 9. So that means that the point -6, 9 is on this graph. So I'll plot that in. Okay. Now I could continue finding more function values, but I know because this is above this x-axis that it's going to stay there. So I can, given this is a rough sketch, I can fill this in. I could find more function values if I want, but I know that it's going to have that behavior. How quickly it reaches that horizontal asymptote of y equals 2, I'd have to analyze more numerically to figure that out. But I've got the general shape in there. Now, the next thing we need to know is what happens between this vertical asymptote and our 0. And really, so we're really looking at right here, but we already have that vertical intercept. So technically, we've already figured out what happens there. And all we would do is find a point between those two, but we already have. We've already found r of 0. So we know that our function is going to go from this 0, or this horizontal intercept there, which we determined by the 0, to that vertical intercept, and then head down. The last thing that we would want to determine is what happens on the other side, so over here. And we can surmise that it's going to stay below that line y equals 2. But if we want to look at that numerically, we could take let's take r of 6 and plug that in. So we'd have 2 times 6 minus 6 all over 6 plus 4. And that will be 6/10 or 3/5. So not quite to 1, and I'll plot that point then. That'll be 6, 3/5. I no longer need that question mark. And so we'll go right in there with that point, and then our graph will just continue along. Okay, so at this point the graph is complete. I mentioned at the very beginning that there are more formal ways that we could look at stating the behavior of the function around the zeros and the vertical asymptotes. And the more formal way would be to make a table, and I can show that real quick. I'll add it in here. So what we'd be looking at with this, I'll make that solid, would be to look at the zeros and vertical asymptotes, and then basically break this up. So we know that we need to know what happens over 3 different intervals. And we'll identify those. So those intervals are going to be determined again by the zeros and the vertical asymptote. Okay, so we need to know what happens from -∞ to -4, and then from -4 to 3, and then again from 3 to infinity. And so what we're really doing here is looking at the zeros and the vertical asymptotes, and we see that there was -4 and 3 were those breaking points. Okay, so we need to know what happens over that interval, so we can pick some value of x and then find r of x. And so that's precisely what we did. We took an x value of -6 and found that r of -6 was 9. And then we plotted that point. And so we knew that that point then was -6, 9. Between -4 and 3, that was already done for us because we'd taken the time to find that vertical intercept. So we'll have r of 0 equaling -3/2, and that was the point 0, -3/2. And then the last one on the other side, we picked an x value of 6, which 6 lies in that interval of 3 to infinity, and r of 6 had a value of 3/5, and so we plotted the point 6, 3/5. And so this is just a more formal way of finding all of those, finding those 3 other points that we needed there.